Check, check, check. Just waiting for my students to come on. We are using a new way to connect to me. We're still going through Google Live, and I am going to open up a chat room on HipChat. Okay, I have emailed you all a link, I believe, and I also have the link posted above this live feed. So if you have questions, it'll be easy for me to view that as we go forward. Still waiting for my class to join. If you can hear me, please take out your reference table, and we'll need that. We're going to go over last night's homework for those who did it. I want to go over just a couple of questions that many people found troubling, and I want to teach you something new today. Okay, so please get connected if you haven't already. We should be settling in. I'm waiting for people to connect with me. All I need is today is Miss Magello is going to put her laptop and put on the big screen, so we don't have to do individuals, so that you can be using your laptop to ask me questions. So still trying to get a connection. La la la. Okay, looks like someone is linked on. And if you can hear me, I'm looking for everyone to take their laptops out. And there should be a link under week 10 of today above this live feed for a chat room so that you can ask me questions as we go through this. I am reviewing a couple of questions on your homework, and I am going to teach you something new. Okay, thank you. So my conduit is now Miss Mangello. Please have everyone use their computers if they want to join the chat room. There's a link above the Grodsky feed, and we're going to get started very soon. Okay, good. You're taking out computers. So what I'd like you to do is I'd like you to take my screen, share it. Okay, and I want to go to, I always like that. All right, if I take out, all right, so I've got Sam already hooked up saying hello. And hi, Sam. This is a good way for us to probably talk to each other. Okay, and all Sam did was, I believe, Sam linked up from today's live chat. He just linked up here, I believe. Clicked on here, they asked him his name, and we're ready to go. So I'm going to kind of go back and forth. Ms. Mangello is also going to be able to text me if there's a question or something's not going right. So we're going to start with the homework, okay? And again, just checking out who's with me. So far, it's just Sam. But any case, you should be able to take that link. I also emailed you a link, I believe. And as everyone joins, Lily's with us now, and so forth and so on, okay? So you should be doing that. So you should be able to see me on the big screen, be able to talk to me through your computers, and hopefully this works out a little better. Okay, so any case, I want to start with the homework. Now, not everyone did the homework, and I don't know if it's a function of I'm not here, so you're not going to do anything, but I'm still here, okay? Any case, homework is going to, the homework over the weekend is going to be Cat 10. I have posted it. You can download and print it, but you're going to put the values in the form. Anyone who did the homework tonight is going to get extra credit, and I explained that in the email back to you. So I want to spend some time going over the homework, at least the ones that people got wrong the most. So let's do that. So let's get statted, as we would say in New England. All right, so I'm going to start with last night's homework. And here we go. All right. So I'm going to start with number 7. And of course, if someone has any other questions, the reason why I'm starting with number 7 is 36% of the people who did the homework got number 7 wrong. Okay, number 7 states, which chemical bond between two is the most polar? Again, they're talking about the bond. Most polar must mean you're creating the biggest differences, meaning the what? The greatest unequal sharing, right? These electrons down the middle, it'd be nonpolar. But if something is polar, you're going to have electrons between two atoms that are being shared the most unequally. How do I know that? Where can I find that? The word is electronegativity difference. We've been saying this word over and over again. Electronegativity is the attraction for other people's electrons. So what you had to do was see who has the greatest difference in electronegativity. You're going to subtract the electronegativities. Yes, we've talked about this. Okay, so hydrogen to hydrogen is going to be a nonpolar bond. Why is it nonpolar? Because they are the same electronegativity. Look, hydrogen is 2, I believe 2 minus 2.2. that's going to give you a 0. So we forget 4. Now it's down to these others, and I've already told you polar bonds are from 2 different nonmetals because they have 2 different electronegativities. So if you're not sure how to do this, we have sulfur and chlorine, carbon and nitrogen, and silicon and oxygen. Okay, if you go to a periodic table and see if I can pull one up, looks like I had one up, but I don't know where it is now. Okay, you would see that carbon and nitrogen are very close to each other, and silicon chlorine are very close to each other. The one that's the farthest difference away would have the greatest difference. Now, if you don't like that, all you've got to go is to table S. So let's go to table S. Okay, table S is, some people haven't been there yet or they don't know how to use it. And here I am in table S in all of its glory. And let's look at silicon. Okay, if you can see this, I'm going to make it bigger. Silicon is right here. Its electronegativity is 1.9. Okay, oxygen is 3.4. So in silicon and oxygen, all I've got to do is subtract 3.4 and 1.9. And what do I get? Okay, I get, well, 1.5 difference. The difference in electronegativity is great. Therefore, they're sharing unequally. The stronger one, oxygen, is pulling electrons what? Closer to it, which makes it different, have a pole more negative. Look at carbon and nitrogen. They're right next to each other, so they're not going to have much difference. The difference here for carbon and nitrogen is 3.0 minus 2.6. 3.0 minus 2.6 gives you a 0.4 difference. Not much difference there. Almost nonpolar. Okay, very little difference in attraction or strength. So they share almost equally. And then the other one was what? I believe it was carbon, sulfur and chlorine. They're right next to each other. So their difference won't be great either. Okay, and if you have to, subtract it. 3.2 minus 2.6, what's that going to give you? That's going to give you a 0.6 difference. So of the choices, you have a 0 between H and H, a 0.6 difference between sulfur and chlorine, a 0.4 difference, okay, for the carbon and nitrogen, and the biggest difference, of course, is between the silicon and the oxygen, because they're the farthest away on the periodic table. Okay, therefore they're the greatest difference. But look at table S; it gives you those values. All right. So back to where we were. So the answer is, of course, choice 1. All right. Let's see if there's any questions. All right, as we go back and forth through this. All right. Just nothing at this point. So moving forward, number 9, reason why I picked number 9 is 54% of those who did it got it wrong. Okay. I'm sorry, got it right. Okay, 36% of people did number 7 got it right. So only 54% got it right. What's a polar molecule? This is a different question in polar bond. Well, polar molecule has to have polar bonds. Guess what? This one doesn't have polar bonds. It's bonding to itself. It's a non-polar molecule, so that's gone. The others are 2 different nonmetals, so they have polar bonds. Everybody here is 2 different nonmetals. Therefore, they're sharing unequally. 2 different electronegativities. They'll have electronegativity difference. Now, you've got to look at the shape. Okay, a polar molecule is going to be asymmetrical. Look at choice 1. Choice 1 is going to be that symmetrical methane where you have H's all the way around in a tetrahedral. That's symmetrical. The polar bonds will cancel out. CO2, if you do the Lewis dot diagram, you'll see that there's no lone pairs of electrons to bend this downward. So CO2 is going to be linear and very symmetrical. That leaves me with NH3. If you do the Lewis dot diagram, and that's why I think people got this wrong, they didn't do it. You can't look at the structure. You've got to think with the dots. What? Hydrogen, nitrogen has 5 valence, hydrogen has 1. And this is the proper Lewis dot diagram. You see that it's not the same way around. There's a lone pair up here. It's not the same, so it's asymmetrical. The polar bonds don't cancel out. And this is going to have a negative side, but okay, on top, and a positive side on the bottom. And that's why choice 4 was the answer. Okay. Moving forward. Number 10, which term indicates, number 11, 63% of y'all got it right. So they said XCl is classified if it's ionic. Ionic means you have a transfer. You're pulling the rope away. Someone's so much stronger. Okay, we've done this. Kara got the rope pulled away from her because I was the non-metal. So I've got an X and Cl. What kind of compound must be X? Well, Cl we all know is a non-metal to halogen, very electronegative. So I need something to be a metal. Silly, silly rabbits. Silly, 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 silly. This is a non-metal. Okay, iodine's a non-metal. Here's my Waldo, a non-metal. Rubidium is an alkali metal. It's the only metal. What did I tell you? When it comes to atomic structure, when it comes to periodic table, when it comes to bonding, you're going to have questions where they basically deriving or at least making you figure out metal versus non-metal. Okay, you need a metal here that holds on to electrons loosely so that it can transfer. And Cl can be what? Have that 8 and be negative. Okay, so that's why that is. All right, number 13. 63% got this right. Who are covalent compounds? Now, covalent means non-metal and non-metal. Well, my friends in chemistry, choice 1, carbon's a non-metal, hydrogen's a non-metal, oxygen's a non-metal, non-metal, non-metal. Choice 1, metal, non-metal, ionic, metal, non-metal, ionic, metal, non-metal, ionic. Okay, now we're going to see today this doesn't always work, but an easy way to decide between things that are covalent is the idea that it's nonmetals and nonmetals sharing electrons. Is there any other questions on this quiz? Those are the ones that were marked the most wrong. Okay, let's see if there's any other response. I know there is a delay, although it's funny, I don't hear myself in the room today, but that's probably a good thing. Okay. So I am not seeing any questions up to this point. So let's continue with today's lessons. And I'm going to point you to number 14. Tahira mentioned something, and I didn't mark this against you. So Tahira brought this to my attention. There was one thing on the quiz that probably wasn't fair yet. Now, she didn't say that. She just said there was no answer. And according to what I've told you, she was right. And it wasn't 14. It was, what is this here? Oh, this is the wrong thing. Okay. So we want to go back here. So 14, I believe it was. Here we go. Okay, which form represents an ionic compound? Okay, at number 14. All right, number 14. I don't know why I have this one up. I don't want this. I want my Java. Or, 14, here we go. Which one's an ionic compound? All right, well, ionic compound's a transfer. Someone who loses with someone who gains good, transfer of electrons. We should have this down by now. But it should be a metal and non-metal. Non-metal, non-metal, non-metal. Bang. Non-metal, non-metal. Covalent. Non-metal, non-metal. Covalent. And if you use this understanding non-metal, 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 you'd think that number 4 is also can't be ionic because there's no metal. And it's certainly not just about metals. So let me talk to you about what we're going to learn today. What we're learning today is compounds that are ionic that have clusters of non-metals. Let me explain. So let's make some room here. Okay? From what I've taught you so far, Tahir is right. There is no answer here, and that's why I did not mark this against you. Now let me explain what's happening. There are clusters of non-metals that can be ions. Really, what is ionic? Ionic means that you have essentially something positive electrostatically attracted to something negative. Now, it just so happens metals love to lose electrons, and nonmetals gain electrons. So we've been talking about metals and nonmetals transferring electrons to become ions and becoming ionic. And that's the most simplistic version. But there are other ionic compounds. Remember, to be ionic just means that essentially positive and negative ions are attracting. And I shouldn't draw these brackets, really not yet, because what I should be drawing is that these things make what? Crystals. Yes, we can't get away from the crystal formations they make in all directions. So if the bottom line for ionic is that positive and negative ions are needed, there's going to be some scenarios like this question where you may not have a metal. And let me explain. Okay, let's take nitrogen. Okay, nitrogen, let's take ammonia, NH3. And we kind of drew this before in another question. Now, NH3 has 1, 2, 3, 4, and 5 valence electrons. Each hydrogen brings 1 to the table. Now, you notice there's a lone pair of electrons that are just sitting up here for the nitrogen. There is things in nature that we're going to learn in acid and bases called H pluses. They're H plus ions. If we go back to the periodic table, we learn that an H has a 1/1. It's got 1 proton. If it's an atom, neutral. You say atom, I say neutral. Atom. I heard you, Lily. Okay, so this is 1 electron too. And because remember, neutrons, we subtract the mass number from the atomic number. So 1 minus 1 is 0 neutrons. So hydrogen atoms have 1 proton and 1 electron. When it becomes H plus, okay, we must have lost the electron, and all you're left with is a proton. So an H plus sometimes is called a proton. Right? Because to become H plus, you have to lose electron. Well, it only has 1 electron and 1 proton, no neutrons. So when it loses an electron, it's just a proton. And we have these in the environment. We have a lot of them, actually. Things that are acids tend to produce a lot of these. So if you think with me for a second, this nitrogen has 2 lone pairs. Doesn't this H plus need 2 electrons to bond here? And the answer is yes. These 2 lone pairs will attract this H plus, whether you want to call it a proton or a hydrogen ion. This guy brings nothing to the party, and he uses both of them. And what we get here, party people, is we get a scenario where the H, okay, uses both of the pairs of the electrons of the hydrogen to form a covalent bond. Now, because it just brought a proton with no electrons, it made this entire cluster of nonmetals +1. Ooh la la, what just happened? This cluster of what? Nonmetals is sharing, but because a proton, something with 1 positive, okay, was attracted to the lone pair sitting there, and it needs a pair to bond, okay, once it made a bond, it brought a proton with no electrons. So this entire 5 groups of atoms clustered, bonded together, I'm drawing brackets and charges because it is now +1 because of the extra proton. We call this cluster of nonmetals a poly, that means many, polyatomic ions. What's so special about them? They are clusters of nonmetals sharing electrons covalently because they they both have high electronegativity, but they have charges. So my friends, this is called the ammonium ion. It's got a special name. And to get the names of these, we go to table E. I go to table E for you. All right, and I'll find it here somewhere. I call table E, what the heck is that table? All right, so let's see. Let's go to table E, and I call this the what the heck is that table. Now, why do I do that? Because it's a group of cluster of nonmetals. We're so used to our ions being monoatomic ions, like sodium plus. So you're going to see a cluster of stuff that you're going to say, ooh, what is that? What the heck is that? So eventually when I get to table E, you'll see it, and here it is. So table E in all of its glory is the what the heck is that table. And if you look carefully, party people, or people that want to go to the party but don't know where it is, okay, or people that want to go to the party and someone told you the wrong address, okay, I'm not speaking from any experience. You have the ammonium ion. Look at that. It's all listed for you. So these are mostly clusters of what? Non-metals that are bonded covalently, okay, but they have a charge. Oops. Okay, so let me explain. Let's give another example. Look at the hydroxide ion. Now, people tend to confuse this because they see the ID ending, but the hydroxide ion is -1. How did that happen? So watch with me. Oxygen has 6 valence electrons. It's bonded to an H. This H has 1. What do I teach you? Evaluate your structure. By sharing, oxygen only has 7, and by sharing, hydrogen only has 1. We have learned that this wants to have 8, the octet rule. This wants to have 2 and fill its energy level. So everybody understand that this thing to be stable needs what? Needs 1 more electron from the environment. So these 2 electronegative atoms, okay, will pull a what? An electron from the environment. So it pulls this electron from the environment and now is happy. But because it pulled an electron to make it work so that oxygen can have 8 and hydrogen has 2, the entire structure is now an ion, and you guessed it, is now -1. Why is it -1? Because it needed an electron from its environment to make it work right there. All right, and we call it a polyatomic ion. So it's a cluster. So if I said to you, which of the following is ionic, and I wrote NH4 OH, you would say, well, Mr. Grotsky, that's silly, there's no metals. But careful, careful, careful. Now you should be able to say, ooh, there's a cluster of stuff here. What the heck is that? So you said, well, you find the first cluster right here. It's an ammonium ion, as we just discussed. And then we find the second cluster as the hydroxide ion. That means this entire ammonium acts as a +1. That cluster of 5 atoms, this cluster of 2 atoms is -1. And my friends in chemistry, you have an ionic bond between the 2. And guess what? They make crystals, right? You're going to have the ammonium H+, NH4+, attracted to an OH-, this OH-, NH4+. Okay, they make crystal lattices because they're ionic. There's no metals here. So the best definition of ionic compound, yes, transfer of electrons, yes, metal, non-metal, but the best overlapping one is that positive ions are attracting negative ions. Okay, sometimes these clusters gain electrons to make them work. Sometimes they gain protons, but they're already ions. Now, naming these types of salts, and these are salts, guys. A salt is an ionic compound. All right, last time we named salts, if I had sodium, let's say chlor and chlorine, these are monoatomic. We had sodium and chloride. Now when we name polyatomic ion salts, we name them with their names given to us. So in this case, I would name this ionic compound to be ammonium, because that's what's in front. I don't add anything. I use the name. The OH group is called the hydroxide. Okay? Ammonium hydroxide. Now, there's one more piece to this. If I've got ammonium hydroxide, and there's a bunch of different ones, but I'm just going to draw some here. If I have ammonium hydroxide, and I'm just going to make one down here. Let's just look at it carefully. If I have ammonium hydroxide, here's my ammonium. and we know it's a positive ion. It's attracting the OH minus, that's a cluster. Clearly, the ionic bond between ammonium hydroxide is between the ions, the positive one and the negative one. I'll write that different colors. This is positive 1, negative 1. But wait a minute, can anyone see where the covalent bonds could be? Yeah, the covalent bond is inside the cluster between the O and the H. Hey, between the O and the H, my friends, right there. That's a covalent bond. So inside the cluster, what keeps the cluster together is a covalent bond. So anytime you've got a salt that is using these clusters called polyatomic ions that's listed to you in table what the heck is that, you have both ionic and you have covalent bonds working. So we say, and if I ask you, and I will on your cat, I will eventually, which of the following chemicals has both an ionic and covalent, you will look for a compound that's using these structures. For instance, let's look at another example, okay? Let's look at another one. Let's say I had sodium, all right, let's write the name of it, sodium nitrite, or nitrate. What the heck is that? I know what sodium is, Na. It likes to become positive. What the heck is a nitrate? Well, my friends in chemistry, there it is. Nitrate is a cluster of nonmetals that, in order for them to work, in this case, look at the charge. Negative means -1. It needs an electron from its environment, just like what hydroxide did, to make it work. So sodium nitrate means you have this whole thing is -1, this whole thing is +1, and the chemical formula is NaNO3. You need one positive for every one -1. And what kind of bonds does this have? Well, the ionic bond is between the ions, the two, in this case, the metal and the cluster. And where's the covalent bond? The covalent bond is in between the N and the O3. You are not responsible for having to draw any of these Lewis dot diagrams, for the most part, of polyatomic ions. But you are responsible for knowing that salts include chemicals that have both, they could have no metals as long as they have positive ions. So you're responsible for knowing that polyatomic ions can now be involved in salts. And you are definitely responsible for identifying compounds that have both ionic and covalent. So back, make sure we have no questions. I haven't checked in a while because I got long-winded, and it happens at this height. And I don't see any questions happening. So you are just totally in tune and understand, and I'm as clear as I possibly can. So when we go back to our homework, which of the following represents an ionic compound? You have to now say, oh, I see a cluster. That cluster is the ammonium ion. That is acting as a positive. The chloride ion is negative, and that is ionic. That wasn't fair last night, but going forward, it is now fair. Right to here? All right. So let's do a couple of other examples and do some naming as we leave today. All right. So let's go back to our table whatever, E. What the heck is that? All right. And let's do some more naming. Okay. So let me get rid of this guy, maybe. Let's do some more naming. So what if I said to you, I have calcium hydroxide. So someone said, what's the formula of calcium? There's my metal. Gives it away. It's not covalent. Hydroxide. Okay, now hydride would be that single H. Calcium, we know from the periodic table, is +2. All alkaline earth metals are. Hydroxide. What the heck is a hydroxide? There it is. It's an OH, it's a cluster. That entire cluster is -1. Now, how do I write the chemical formula? Well, we crisscross, remember that? Remember jump? Wiggada, wiggada, whack. Okay, so this goes here, and this goes here. And you crisscross, always reduce to lowest terms. What we get is 1 calcium, but we're gonna need 2 hydroxides, aren't we? Right? We're gonna need 2 hydroxides. Each cluster is -1. And if one of these is +2, when we write the chemical formula of a salt, of an ionic compound, it has to be the lowest ratio of the ions in a crystal. So you need 2 of them. This would be wrong. If you put a 2 here, that would be wrong. You need to throw in parentheses because each cluster is -1. This 2 means 2 of everything inside. So the chemical formula is Ca2, and we put a solid because it's ionic. This is a cluster, and you need 2 of them. The reason why we put parentheses is because we need 2 of everything inside. Does that make sense? Does that make sense? Sounds like it might be. I know there's delay. All right. So let's try another. What if I have the name, let's get rid of some places. What if, and by the way, does calcium hydroxide have covalent and ionic bonds? And the answer is yes, it does. It's got an ionic bond between them, and we have a covalent bond between the nonmetals. So we have an ionic bond between the positive and negative ions. Right here is what I'm drawing. And then we have what? Sharing electrons between the nonmetals. All right, I guess those beeps mean someone may be chatting with me. Lily says, sort of. Okay. What specifically are you having trouble with? And I'll let you beat me in. All right, let's do another one. Let's do another one. Let's do, you tell me the name of this. NaHCO3. Try to give me the name of this. First thing, is it a salt? Well, the metal kind of gives it away. Remember, when you name them, you name the things in front. So I see sodium, so I'm going to split this. All right. Well, sodium is written in front. And this cluster, what the heck is this cluster? Well, go look at the what the heck is that table, party people. And it's called hydrogen carbonate. So it's sodium, hydrogen carbonate. You write the name of the entire polyatomic ion. So I'm not really stressing naming right now, but you should recognize that this has both ionic and covalent bonds. Okay, it is on your CAT. Your CAT is take home. Please review this lesson if you need it. Okay, you must enter your responses in the take home in the form. All right, sorry I'm not here to get your questions individually. I know a few people have things they owe me. Just keep emailing me, checking the accuracy of your grades. I will be in Monday. Have a great weekend. Please do your CAT by 12 p.m. tonight. I'm sorry, 12 p.m. Sunday. Take care.